everyone! In this video, I will be going over the methods to the challenge problems from the last permutations video. The first problem is how many ways can 10 distinct objects be placed in a circle if two objects cannot sit next to each other? This question is a perfect example of inclusion-exclusion, or taking the complement of something. You can try to calculate all the ways of arranging the objects, but it will be much harder than just doing the opposite. The idea is it's much easier to just calculate all the ways in which everything can be placed together, so 10 objects can be arranged in a circle, and then all of the ways in which two people are sitting next to each other. So then you can just subtract out what you don't want from the total possible arrangements to get what you do want. Okay, from the last video, the total number of ways in which we can sit 10 people in a circle is 10 minus 1 factorial, or 9 factorial. And all we need to do now is find the number of ways in which two people have to sit next to each other. The best way to think about this is by lumping two objects together. We'll put A and B together, and then think about them as one object. So now we have 8 other objects plus this one lump, which is 9 objects total. And the number of ways of arranging 9 objects in a circle is 9 minus 1 factorial by the same principle. However, there are 2 ways in which the seating arrangement of A and B can take place. So A can be sitting on the left, B can be sitting on the right, and vice versa. And this is true of when you place that lump in all 9 seats. And because these 2 arrangements are different, the total number of ways in which we can sit 2 objects together in a circle of 10 is 2 times 9 minus 1 factorial. And now you just do the math. 9 factorial for the total number of arrangements, and then you subtract out what you don't want, which is 2 times 8 factorial, and then you just do the math to get what you want, which is the total number of ways in which 2 objects cannot sit next to each other. Okay, challenge problem number 2. What if the neighbor seating... Okay, challenge problem number 2. What if neighbor seating is arbitrary? So it doesn't matter which side J and B are sitting on in relation to A. So in this case, these 2 scenarios are considered the same. So how is it possible such that A can have B and J on either side while still keeping the rest of the circle in the same positions? So if C is sitting next to B in the first scenario, C must also be sitting next to B in the second scenario. And actually, there's only one way to do this, and it's with a pancake flip. So if you take one arrangement, the only other way in which you can have reverse seating such that everybody still has the same neighbors is if you took the whole table and you flipped it over like a pancake, giving it the mirror image. So these 2 scenarios are exactly the same. And both of these arrangements are counted in that 10 minus 1 factorial. So if we say neighbor seating is arbitrary, then half of those arrangements are duplicates. So we have to divide out 10 minus 1 factorial by 2. All right, as always, shout out to UC Berkeley's PEACE Tutoring organization. You can check out their website here for more information.